afternoon, everyone. Thank you for joining us. We're very happy to have you in the launch of our webinar series on demand flexibility. My name is Rashmi Vasudevan, and I am a project director at Ensystems Advisory Private Limited. We are primarily based out of Mumbai with key offices in Delhi and Goa. We specialize in the energy and environmental sectors, while our expertise spans electricity regulations, clean energy access, water resource efficiency, and sustainable mobility. Since our inception in 2012, Ensystems have developed a strong proficiency in the electricity regulatory environment, particularly addressing demand-side management. We have been privileged to support electricity regulators across the country in policy making and tailoring DSM initiatives for discoms. More recently, we supported the Maharashtra Electricity Regulatory Commission in notifying its demand flexibility and demand-side management regulations 2024. These experiences hence have predisposed us to closely study how demand flexibility is an important opportunity to advantage discoms, especially in the light of India's fast-paced growth in grid-connected renewable energy assets. With 212 gigawatt of installed capacity, accounting for 45% of the country's energy resources, renewable energy is already shaping the demand profiles. Yet, as we know, discoms are not successfully able to rely on renewable energy to address their typical peak demand challenges. To this end, this webinar series is positioned to explore the opportunities and challenges in flexing the demand of a few select end-use consumptions that can be ramped up or ramped down selectively to optimize renewable energy uptake. The webinar intends to strengthen the demand flexibility narrative in the country, which is still evolving, and create visibility for opportunities and also create an essential fact check for technologies that will enable flexibility. Before we delve into today's discussion topic, that is peak shaving by shifting water pumping energy demand in public utilities, I'd like to quickly introduce our remarkable panelists who have joined us today. Ms. Girogia Pasqualetto is a senior officer at the Energy Transition Planning and Energy Efficiency Department of Sustainable Energy for All, which is a UN entity. With over 6 years of experience, she has worked in strategic planning and engagement with the G20 and UNIDO, promoting industrial energy efficiency in Latin America and Eastern Europe. Moving on, bringing a strong regulatory perspective, Dr. Sanjay Verma has held key roles in the past. He was the director of Tariff at the Haryana Electricity Regulatory Commission, and he brings more than 25 years of expertise only in the just alone looking at the regulatory and tariff matters. He has played a key role in shaping Haryana's energy landscape and addressing critical challenges. Ms. Sujatha Guruji, who is the head of demand-side management at Tata Mumbai, brings more than 18 years of experience in the power sector. She leads the designing and implementation of innovative DSM programs, promotes consumer awareness for green energy solution and rooftop solar net metering. And to bring perspectives of demand flexibility opportunities and challenges in public utilities, we're very glad to have Mr. Charankar, who was previously the Deputy Municipal Commissioner at BMC, Mumbai. In his vast experience, more than that spans more than 20 years, only dedicated to water waste and environmental engineering initiative, where he has extensively worked in public utilities and municipal governance. Not the least, we have Mr. Sumedh Agrawal, Project Director at the Alliance for Energy Efficient Economy, to help us reflect on the broader conversation opportunities in demand flexibility. With 18 years of international experience in utility modernization and net zero technology development, he has led innovative programs on demand response and integrating resource planning, improving efficiency and advancing greener electrical grids. With this, I'd like to invite my colleague, Kaustubh Arekar, who is a project coordinator and leads the modeling activities for the power sector activities and demand flexibility in particular, to walk us through some of our perspectives and learnings in demand flexibility and primarily looking at the opportunities for shifting demand in the public utilities. Kaustubh, over to you. Thank you.
Thank you. Yeah, so I will be presenting a short presentation on the energy demand flexibility context and also the assessment of the demand flexibility potential in the water pumping systems. So these are the contents for the presentation. So, first we will talk about what is demand flexibility. So demand response, we consider demand flexibility as a combination of demand response and also accounting for flexibility that will be required for RE integration. So combination of demand response and flexibility, we are considering it as a whole as a demand flexibility. So why it is required is in this way. So in the older way, the load the generation was following the load. So as per the demand, generations were scheduled. But with the higher integration of renewable energy, those renewable energy are not schedulable generations. So now there is need from the demand side to follow the generation that is available, which is also like depend on the environmental factor like irradiance and wind speed. So these are the broader objectives for the demand flexibility programs. So first is the RE integration prioritization. So we have a 2030 target of integrating 500 gigawatt of non-fossil fuel energy in the Indian power grid. Then the second most important objective is the optimization of utilities power purchase cost, considering all the expensive power purchase that is required for the peak demand, then also additional infrastructure that is required for RE integration. How we can minimize it by aligning the demand side in a way, in a such a way that it will the most of the RE generation that will be coming up will be utilized in that RE hours only. Then, if we want to do some demand flexibility projects or the programs, then consumer participation is very important. And for that, the demand flexibility program should also think about how the shifting and adjusting loads can also contribute to reducing the energy cost to the consumers. So, in the Indian context, the installed renewable energy capacity is increasing for a decade, and now it has excluding large hydro power plants, we have reached around 167 gigawatt of installed renewable capacity, which includes wind, solar, small hydro, biomass, and waste to power. So, in the graph also you can see the solar contribution from solar and wind is highest among the others. Then how this integration is changing the energy markets specifically that we will see. So the graph, so we have plotted the day ahead market prices, sale bids and the purchase bids for the day ahead market and green day ahead market for 2 months. So the first slide is about April overview. So the graph shows the average sale bid, average purchase bid, and the average MCP that was discovered in different slots for the day. So it can be clearly seen in the solar hours, the availability of generation, that is the sale bids are higher and which is contributing towards reducing the prices in this particular period. In the green day ahead market also the similar trend can be observed across the MCPs. Then so April was a high demand period for the India, and it is summer peaks are observed in that period. So considering the November prices and the energy market overview, so for November 2024, the similar pattern can be observed, but there is additional things that just before the starting of the solar period, there is sharp decline in the availability or the sale bids, and after the solar period also there is decrease in the sale bids, and that is creating two peak of MCPs. And for the GDAM market, again, the availability of the power during the solar period is higher and then it becomes constant. So we can see there is a dip in the market clearing prices for that period. So this trend can be expected to continue with the higher and higher integration of renewable in the energy sector of India, and it will be optimal to use most of the energy during this period. Now coming towards the factors that are important for assessing the requirement of demand flexibility for any discom, and what is the readiness of the discom for implementing such programs. So the requirement, in the requirement part, we have variation in load. So discom with higher load variation, like say the ratio of the peak demand to off peak demand, daily ratio of peak to off peak demand plays a critical role, because planning the generation uh, is difficult in that case with if the variation is high. Then also, what is the RE mix that is integrated into the generation mix of discom? With increasing RPO targets, this RE mix is going to increase for every discom. And then CAGR in peak demand. So with the peak increase in peak demand, there are two factors that contribute to increasing cost. So we need to uh, tie up with additional generators. Also, we need to uh, create the infrastructure to support this additional load. Then seasonal variation is also observed in some states where uh, there is significant difference in the temperatures are observed. So, for example, in Delhi, the summer load and the winter load are like significantly different. So, in that case, also DF can help in optimizing the power purchase cost. Then recently also, I think that in Kerala, the increase due to the increased charging of EV, there is stress on the grid, and the actual total consumption is also increased for first January and February compared to the last year January and February. And also, it is also said that the loads are also coming into the peak time. Then so that is also a factor that has to be considered. Then if the discom is generally having a higher power purchase cost to suffice the peak demand, and due to the fixed demand charges that are there for the PPAs, then also the demand flexibility can be used for optimizing that. Coming towards the readiness of the discom to implement such programs. So as we know that the electricity distribution business is a regulated business in India. So proper DSM regulation framework is required to uh, build a business case for the demand flexibility and demand response. And also it should give some support to discom, that you can provide incentive under these programs to the consumers for supporting the grid and so on. So this framework will be critical factor for the readiness. Then what are the resource advocacy regulation also talks about considering demand response from the consumer side as one of the resource for planning the resources for the future energy needs. Smart meter installation in different consumer categories is important, because for implementing any DR, MNV is required, and 30-minute or 15-minute energy measurement will be required. So for discoms also, for identifying like what consumers to target first for the DR programs, the smart metering installation in categories can be assessed. Then the utilities that have already have implemented some pilot DFDR programs, they are more ready than to implement large scale programs as well. Then consumer awareness also plays a crucial part, because currently all the programs are behavioral demand response, which depends on the consumers to change their loads in certain period of time. So consumer awareness becomes critical. Also, the last point is battery storage installation. So discoms in India have started installing grid level battery storage for different objectives, like for feeder level optimization or for absorbing higher RE. So if discom is already planning for battery storage installation, then that discom is more ready for the programs. Then coming towards the Maharashtra Electricity Regulatory Commission regulation on the demand flexibility, which was notified in the 2024. Uh, it has set up a implementation framework for DISCOM to implement such programs. Also, cost effectiveness assessment framework is provided so that DISCOM can estimate the impact of such programs on the DISCOMs as well as consumers' finances to ensure that the DF programs are not negatively impacting any entity. So this will ensure that the consumers as well as DISCOM will get benefit from the programs. Then evaluation and measurement verification framework is also provided. The interesting part is that the regulation also talks about DFPO targets, which are similar to RPO targets for the DISCOM. So DFPO target stands for demand flexibility portfolio obligation. So currently there is 5-year trajectory which is starts from 1.5% in first year and gradually increased to 3.5% in the fifth year. And also the incentives are linked to these targets so that DISCOM will actively pursue these measures. Uh, Also, the regulation also talks about third-party independent verification contractors to ensure that the impact of these programs is properly calculated and evaluated. So there are different demand flexibility interventions that are possible. So I have listed a few of them. So first is demand flexibility in bulk water system, which is the today's topic, and I will be talking about that in more detail in coming slides. The second one is cold storage facilities. As we know, the cold storage facilities has thermal inertia, so they can defer their demand for a short period of time to give a response to the grid whenever there is a requirement. So this is one of the opportunity. Then we have managed EV charging. So there are technologies that are available to manage electrical vehicle charging in unidirectional and bidirectional ways, and they can support in the ancillary services market to support the grid to in challenges if the local level challenges as well as grid balancing challenges. Then we have a heat pump for residential and public buildings and as well as hotels. So the heat pumps provides two opportunities. First is the energy efficiency. So the energy requirement in the heating load can be reduced substantially by if we introduce heat pumps for centralized heat pumps in the buildings as well as the hospitals. And the with the storage, heat pump with storage can also provide opportunity for the DISCOM to operate this kind of equipment in an off-peak period so that these loads will not contribute to the peak demand. The fifth one is thermal storage for the commercial building. This is similar to battery storage, but it is specific for the HVAC load, where the HVAC load thermal storage can be used in the off-peak period, and then that the stored ice or PCM-based energy can be used in peak period, relieving to relieve the grid from the congestion. Now coming towards the public water utility load. So there are three characteristics that I have put on the slide. So first is these loads are concentrated ones. So for each consumer, you have a bulk load connected. So those loads are can be in the range of megawatts, and the and they are easier to aggregate. So, for example, from 10 public water uh, work loads, the demand response that we can get is equivalent to thousands of the demand response that we can get from the thousands of residential consumers. So, aggregation becomes easier for the concentrated load. Then there are large water reservoirs to store the water, and those allows shifting of pumping operation. So they gave some flexibility in their operation. And the last one is modular operation. So this megawatt load are not concentrated in one equipment or the one motor. There are multiple motors running in parallel. So for shifting or reducing the demand of from the public water works for a short time. The partial motors, number of motors can be modulated, and that will also ensure that the service constraints are not violated. So for assessing the flexibility in one of the pumping station, we did a site visit and understood discussed with the site engineer like what are the constraints and how the actual work the pumping operation takes place and so on, and identified like how much theoretically can be is possible to shift the demand. So for example, the main component of the water supply systems are shown in the figure. So water sources can be a river or a dam or something like that. And then water is pumped from that source to the water treatment plant. And then this water treatment plant, from the water treatment plant, it is stored in the reservoir at the water treatment plant. And then from WTP, there is second stage of pumping from where the water is pumped to the elevated reservoir, and from that elevated reservoir, it is distributed to the city or any service area by by means of gravity. So there are major energy consumption happening in the pumping station one, stage one. Then there is a little bit energy that is being used compared to the pumping in WDP also. And then there is stage two pumping station where the pumping happens. So, for example, the current situation is like this. There are total five motors with 850 kilowatt capacity each. Currently, out of five, three are running for 24 hours, and uh, the one motor is run for 3 to 4 hours a day. So there is some time where four motors run, but continuously only three motors run. Then there is also in the stage two, there are total eight motors installed, and the capacity for each motor is 660 kilowatt. And currently, only five motors are used continuously for 24 hours. So, continuously. And if we consider the capacity of elevated reservoir, so the maximum capacity it can go is about 7 meter level. Current utilization of that capacity is only 1.8 meters, so it is 25% utilized only. So we suggested the pumping station that if we can run this additional one motor that is they are using for 3 to 4 hours a day in a off-peak period or a solar period. And for the stage two, so there are five motors running continuously. So we suggested we can use this reservoir capacity and increase the operation of pumping station in off-peak or solar period. So we can run six motors for the off-peak or solar period, and the level of this elevated reservoir will go up. And then that additional that storage can be used in the peak period where you can basically reduce your operation of from five motors to four motors. So in that sense, we can achieve this flexibility in the water supply system. The only thing is that we have to consider a mass balance flow for the reservoir. Like if we are uh, increasing the operation to six motors, then in how many hours the uh, level will increase? Like what will be the rate of increase of level with the additional motor? But we assume that the 7 meter is sufficient and can be used for 3 4 hours at least. So this is the detailed calculation. So for stage one and stage two, we are considering if we are shifting this load into the solar period and how much percentage of load can be shifted and what will be the peak demand in the solar hours. So currently the peak demand is around 5.8 megawatt combining, and we can shift around 1.5 megawatt to the solar period. So the total peak demand in solar hours would be 7.36 megawatt, and which would be like around 25% of shift considering the current peak demand. So this is the assessment for a pumping station. Then Tata Power also did a pilot project with BMC pumping station in Bandu, and they could shift around 345 kilowatt for 3 hours daily. So the total demand from the maximum demand from the Bhandu pumping station is 7 megawatt, and out of that, they could around 0.34 megawatt was shifted. Now coming towards the cost effectiveness test consideration. So currently we are so the slide shows what are the costs that have been considered for the TRC test, RIM test, and PCT test. So for the TRC test, the cost that is considered is cost of network operating center that will be required to communication and operation of the uh, pumping stations that will be enrolled for this type of program. And there will be admin cost and cost of MNV that will be annual basis. And the saving is calculated as from the for simpler calculation, we have considered that there is difference between the APPC, like average power purchase cost for non-solar hours, and the APPC for the solar hours. So APPC for solar hours is lesser than the non-solar hours. So that arbitrage will be benefit for the discom if we are so the whatever the energy that is shifted multiplied by the difference between those two APPC is considered as a benefit. So the benefit is similar in the RIM test, but we have added one additional cost, which is incentive to consumers. So for enabling the demand flexibility from the consumer side, Discom can pay incentive to the consumers, and that cost will be added as a RIM test cost, which is basically the benefit as considered from the participants' point of view. And the cost for the participant is we have not considered any cost because there were no additional infrastructure that has been considered that will be required for doing such program. Then the last thing is about the case study in California. So Santa Rosa Water is a water utility in California. So they are also participating in demand response program under the base interruptible program by PG&E utility. So for the participating consumer receives monthly payment based on their curtailment that they are committing. So the table shows the level of reduction and what are the options that consumer is selecting. Like if they are ready for 30-minute curtailment or 15-minute curtailment, and based on the time of year, like November to April and May to October, have different rates. So if even if the event does not happen, consumer gets the monthly payment. So that is the incentive for the consumer. So in the first quarter of 2023, the utility was able to earn around 42,000 by curtailing 1.5 to 2.6 megawatt of energy, and they can go up to like 200 kilowatt, which is their 50%, which is over their 50% of electricity use. Then how the utilities managing their operation to participate in the program. So first thing happens is like the water utility gets a 13-minute advance notice from the grid operator or the utility for to initiate their demand response plan. So they use as per Santa Rosa Water Utility, they are saying that the cost of energy or the energy use is proportional to the water that is flowing through their plant. So what they do is they store that incoming water into holding basins for that period of time and reduce the water flow in the plant so that their energy consumption is reduced. They have also their identified non-essential equipments that can be turned off during the events. So they turn off their non-essential pumps, mixer, and other equipment, and uh, provide the demand response. Yeah. So with this, thank.
Thank you very much, Kaustuv. Before we get into the Q&A, I'd like to invite Georgia to give us a bit of an insight on SEforALL's demand flexibility programs in India.
Thank
Kaustuv,
you
would you
very
like to?
Thank you so much, and thank you for having me today at this very important, very interesting webinar. So I won't take much time, but I just wanted to provide a bit of an overview of the ongoing initiatives of Sustainable Energy for All, together with key partners in India currently to support demand flexibility. So currently, SEforALL is working, has initiated this Mission Efficiency India program, has been active since 2023. And if you go to the next slide, please. Mission Efficiency is a global initiative. It's a global collective of organizations, of governments and partners, both from the private sectors and think tanks and public sector, who are sort of coming together and partnering in initiatives to accelerate energy efficiency towards the global goal of doubling energy efficiency by 2030, which was agreed by many countries at COP28, as well as, for example, during India's presidency of the G20. So in India specifically, this is a non-exhaustive overview of the partners that we work with. And in India specifically, we are partnering with Ensystems and with the Alliance for an Energy Efficient Economy, as well as other active partners in the country, to work together on a few different fronts. So just briefly on the next slide, please. We're working together to accelerate energy efficiency and key opportunity within that, with an approach that focuses on elevating, supporting, and investing energy efficiency as well as demand flexibility as a key opportunity within that. So as part of this work, we are working together at different levels. At the national level, we are supporting central ministers, as well as key think tanks and partners with policy analysis and advocacy to sort of align the country's efforts towards doubling the energy efficiency by 2030 within specific sectors. And we're working closely with the Bureau of Energy Efficiency for that through what we call the Mission Efficiency Unit. But perhaps most relevant for today's conversation is the work that is ongoing at the level of states on two parallel tracks. So on one hand, we are working with the partners to sort of identify and support champion states that are sort of taking the lead on implementing energy efficiency action plans and energy efficiency programs. And the focus here, the vision, is to really provide support to develop and to demonstrate large-scale programs that can make a difference on energy efficiency improvements across different sectors. And then getting closer to today's topic, in parallel, we're also working at the state level with regulators as well as utilities to support sort of rapid scale-up of demand flexibility programs. So there are a few different ways we're approaching this, and going back to the elevate, support, and invest approach, the vision here is sort of on one hand to elevate the importance of demand flexibility, right? So with following Maharashtra's sort of lead and example, the vision here is for more and more states to notify and update the demand flexibility programs and regulations, testing regulatory sandboxes approaches, and sort of exchanging experience to sort of accelerate the transformation on the regulatory side. But at the same time, on the support and invest pillars, the goal is to assist utilities and work with utilities on demand flexibility modeling and training and capacity building to really identify specific program opportunities that can be rolled out and then can serve both as demonstration projects, but also sort of experiences that can be scaled up across different states and across the country. And finally, the sort of the need, Kosta was also hinting to that earlier, right? Building readiness across different pillars, right? We have the regulation, resource adequacy planning, pilots, but also awareness is very important. And so finally, we're sort of working, sort of bringing in more partners and collecting resources and knowledge and experiences to build a demand flexibility platform that can really help spread awareness and increase participation ultimately of consumers within demand flexibility programs. So just to conclude, I wanted to flag, maybe last slide, that this work kicked off last year with a workshop with national entities, central authorities, and also utilities and partners and think tanks, where we really identified demand flexibility as a crucial strategy to meet India's goals, both on the decarbonization of the supply side, so towards, for example, the goal of 500 gigawatts of renewable energy capacity, and also to decarbonize the demand side sectors, right, towards doubling energy efficiency by 2030. And a few insights that really helped us shape their vision are shown here. And there was a general recognition that there are already important initiatives going on, both at the government level and within utilities. And the focus now, there's a consensus that the focus now is really to sort of identify the success stories and rapidly scaling them up. In particular, there is a need for more concerted efforts around regulation updates, going back to sort of what I was mentioning before, as well as data collection and technology rollout that can support greater demand flexibility. So there is a recognition within the sort of the experts in the sector that demand flexibility benefits both the consumers and also utilities, but there's a need for more awareness to increase participation and especially to increase gains on both sides, utilities and consumers. And finally, a few of the successful examples that were identified was water pumping, which we're sort of diving deeper into today, as well as applications in agriculture, residential energy use, and behavioral change. So I think this is a key opportunity for the sector, and we are very excited to be partnering with Ensystems, AEEE, and other partners in the countries to really drive this forward. I will stop here, and I'm happy to dig deeper later.
Thank you very much, Giorgia. With this, we have this introductory context setting presentation over, and we would now like to open the panel discussion. We have a really exciting discussion ahead, but in the meanwhile, I'd like to request the participants who have joined us, if you have any questions, please add it in the Q&A box or in the chat box, but we will take up the questions one at a time after the panel discussion is over. So as and when the panel discussion is on, if you have any thought pops up that you need clarification or would like to add more, please add it. We will curate these questions and take it up at the end of it. And we will also help the panelists address these questions one question at a time. I'll start my questions by inviting Mr. Charankar to comment on what we heard in Kaustub's presentation, that we have piloted and demonstrated that some part of pumping demand can be shifted to peak hours. I mean, from the peak hour to solar hours. So what are your perspectives here, taking into consideration of the energy consumption patterns in the public water works, and also some of the opportunity that we have sort of presented using reservoirs to optimize pumping schedules. If you can sort of help this conversation add the opportunities and some of the challenges, then we can sort of build over it and asking others on those lines.
Hello, can you hear me?
Yes, sir. Very well. Thank you.
The service reservoirs or the reservoirs, any water supply system really helps in distributing the water load as well as the demand factor in electricity, because the major cost is of pumping so far as the water treatment and water supply systems are concerned. So in case of pumping, if the majority pumping, if it can be shifted to a non-peak period, then it could be useful for shifting the demand of waterworks. For example, in a particular water supply system, normally the non-supply hours of water are between midnight to around 5 o'clock in the morning. So during this period, there is a possibility that the maximum pumping is done in the reservoirs. Reservoirs are filled up to the maximum height possible, and then from mornings 5 o'clock or 6 o'clock, the water supplies can be started, and the pumping can be considerably reduced if such type of pattern is possible for a water utilities. Of course, this may not be a solar hour of pumping, but it could be a non-peak hour for demand for utilities. Maybe it should be think of.
Thank you. So the opportunity is there, but we have not optimized these opportunities, what you sort of shared here. With that thought, I'd like to invite Ms. Sujatha to comment. Some of the public water work energy demand in terms of volume and energy volume and peak power demand. How large is this, and how does this demand profile compare to overall demand patterns of the DISCOM?
Okay. Just regarding Tata Power distribution, we are definitely supplying major BMCs, which is Bhanduk, Ghatkopar, Versova, and the total connected load from them is 20 megawatt. And you can see from 4 BMC like pumping station, we have approximately 70 million units energy consumption annually. And looking at their demand profile, it's pretty clear they like the demand from water pumping during evening hours is coinciding with our peak demand. So there is definitely potential where we can shift this, like it carries 2 to 3% of our over peak demand. So we can shift that to solar hours or some other non-peak hours.
And how is the pilot that you've done at Bandung? Any sort of insights that you'd like to take forward, and especially now with the demand flexibility regulations in place? Any sort of thoughts that, yeah.
We have in collaboration with Ensystems, we have done the pilot where with BMC Bhandu, where we have shifted their pumping load, like few pumps from non-solar hours to solar hours. And you can say around 300 units daily, we can shift it to solar hours. And definitely the pilot was even appreciated by ministry, and we even Tata Power has received award for it. So it's a huge potential with water pumping. Now the demand side management is not only related to appliances like 5-star appliances or the more energy efficient appliances. Now shifting it to demand flexibility is really needed, and it was proved through this pilot. And even we are in discussion with Ensystems so that we can expand it and use it to shave our peak during evening hours, especially.
Thank you, Sujatha. With the DISCOM's perspective here, I'd like to invite Dr. Verma to sort of share his perspective here. While Tata Power definitely positions demand flexibility as an interesting opportunity, we have a large number of public utilities also in the coming. Largely, these are public utilities. And how do you think the demand flexibility propositions make DISCOMs? Why do you think demand flexibility proposition can make DISCOMs apprehensive about demand reduction and also considering the existing long-term PPAs?
Yeah, thank you very much. Kostu, in fact, has set up a proper perspective, and Girogia and Guruji explained the practical side of it. Now, demand side management regulations, I mean, regulations are, of course, a piece of legislation which has force of law, has been in existence in most of the regulatory commissions for more than 14, 15 years. But then it has been restricted to, say, LEDs, efficient fans, or say 5-star ACs, the impact, at least in the northern states, has not been significant. The load shift, which was the objective of managing demand, did not really materialize. Therefore, there has to be a laser focus in what we are trying to do. Now, water pumping, who are the people behind this water pumping? All these are, in fact, government connections, whether it is public water works, whether it is minor irrigation tubewell connections, or lift irrigations. See, this kind of water pumping and electricity requirement would account for roughly 4 to 5% of the sales volume of the DISCOM and 6 to 7% of the revenue. In Haryana, it would be around 2,000 crore. So there is a need to do something so that the cost involved is reduced and the peak. Why peak? Why do we talk about peak? Because at the margin, the cost of power purchase is extremely high. I mean, cost of, in fact, showed that day-ahead market, term-ahead market, etc., etc. The market, IX, though it may not properly replicate the cost, because that is only a short-term market, and it used to hit 10 rupees, and when it was not capped, more than 10 rupees. So that kind of scenario has to be avoided. Now, coming straight to the issues that we are talking about, the water pumping. Now, what I heard, if that can be summarized in one single sentence, we need to decouple water pumping and instantaneous demand for electricity. This has to be decoupled. Otherwise, if we can share a screen, because this is all about how the system behaves, the electricity system behaves, and how this public waterworks, MITC, lift irrigation, etc. behave. What is their contribution to the system peak? So if we can see the load curve, can we see the load curve?
Yes.
Yes. Now let us see, this is HT industry. Now let us see the load curve of public waterworks. This is lift irrigation. Now, what we see here, these are all government connections. We need to remember this. Now, what we see here, at times, this is hitting the peak. This is coinciding with the peaks. This is a simultaneous peak, what we call 8 o'clock in the evening, or say 1800 hours. This is touching almost the peak. So why bring in things like lift irrigation here? Because this will add to the cost. Similarly, no, we are not getting the waterworks on the screen, public waterworks. Now, if we see the public waterworks again, at 1 a.m., this is contributing 71%. Then coming down 5 p.m., these are lower. Then suddenly, this waterworks will peak. The demand from waterwork will peak at around 8 and 9 and 10 o'clock when the system is also in the peak. And subsequently, when we go into the evening, in states like Haryana, you have evening peak as well. This will again coincide with the peak. So what I'm trying to say is that vis-a-vis system demand, the simultaneous peak of public waterworks, lift irrigation, minor irrigation tube wells can be shifted through various mechanisms that we have seen.
Thank you, sir, for your perspective. We will round back to this, continuing this discussion, and definitely your graph has been very useful for our reflections here. But I'll quickly ask Sumedh to come in here. And so we heard Sumedh raise perspective. And one of your favorite thoughts that you would like to, we've heard you talk earlier also. What is important for nudging utilities to actually take up such demand flexibility programs to reduce power procurement? What do you think is important for utilities? What will make
Yeah.
them?
So thank you, Reshmi, for inviting me and Georgia for providing the platform. So Kaustubh, your presentation was really wonderful. Thanks a lot for sharing that with all of them, and to all the fellow panelists. I mean, they made all of relevant points. So Reshmi, maybe I will try to give 2-3 perspectives to help you understand the cost of power procurement. So first of all, let us understand, and that will be useful for participants, that why demand response or demand flexibility got started in developed countries. That is very important to understand. And then we will get into the power purchase piece. So excess supply was available, but during the peak, there was always a deficit. So that was one of the things which increased the system cost of the entire things. So for example, for Indian discoms also, or for other discoms, we have supply available, but during the peak, uh, it is only for the few hours, which is basically increasing the system cost. Now, when it comes to the power purchase cost, which is 80% of the overall cost of the entire things, if we are able to reduce the system cost in some way or other, that is definitely a big dent, and the cash which gets released can be utilized for other purposes. So for developed countries, it was very clear. Second thing which was very much reflective is that for countries, and Verma sir would be very much agreeing to this, that most of the developed countries, the tariff is cost reflective. So generally they have the variation in the prices, and consumers have peak prices, off peak prices. But India, we don't have that kind of a cost reflective tariff. So again, that is a major constraint where we have to modulate our power purchase cost or the system cost. And that again brings me to the third part, that is the energy security. So we have a discom, we have a consumer, and we have the overall energy security. So if we can use demand and renewable as levers for decarbonization, energy security gets established. So these three aspects come together to ensure that the overall cost of the systems reduces and is able to provide a better service. US has been a leader in DRDF, whatever we say. They have, like Kaustubh was mentioning, I know from the California that they are 10% of the overall utility energy is contributed by water systems, so water pumping. There are many projects which they have done. Santa Rosa was one example. Other projects are there. And once they started doing these things, what they saw was two aspects. One was on the demand charge, that okay, the demand charge got reduced for the future projects. And the second thing is the congestion. The congestion of the power at the time of the peak, it got reduced, which definitely reduced the overall cost. So I'll just hold on here, Reshmi, and if you have any other additional questions, I will be happy to take it.
Thanks, Sumedh. Actually putting the demand flexibility, demand response opportunity in a broader perspective with its legacy to it. I'll quickly connect your conversation back to Dr. Verma and ask him, how do you see the regulatory environment evolving in the country to achieve some of the demand flexibility opportunities? So the need is clear and the opportunity is also clear. We have just taken public water works as an initial conversation in this series. The need and the opportunity is clearly articulated. How do you think the evolution and the way there are few MERC has drawn the regulations, and there are other draft regulations for demand regulation out DR regulations out there. So how do you see this the path evolving, and what else should be there? Thank you.
The regulatory commissions, most of them, they are inclined towards adopting this demand flexibility because of the say the developments that has occurred. What has happened that there is a big gap between the peak demand. Say the peak would occur in few months in this region, say June, July, August. It will touch, say in Haryana, 13,500 megawatt. Whereas the base load demand would be around 6,000, 7,000 megawatt for 6-7 months. In Haryana is little smaller. In UP, the magnitude would be larger, 26,000 plus megawatt peak. And the base load would be around 13,000 megawatt. Rest of the time, what happens? Because all these are tied up under long-term PPAs. And unfortunately, the generation, 73% is from the coal-based thermal power. So that has environmental concerns as well. So now what happens during the off-peak months, since all the power is tied up under long-term power purchase agreement, 25 years, 35 years, and so on. Therefore, in the non-peak, off-peak, what happens? The agreement, the contract, a typical contract is take or pay. Either you schedule power. If you don't schedule, you end up paying minimum. If your schedule is zero, still you end up paying a lot of money. So what happens? If you go to the market to dispose of the surplus power, still you will be getting around 2.5, 3 rupees for a power which would cost 4 rupees, 4.5 rupees per unit. Therefore, these discoms end up with huge trading losses, 300, 400 crore in a year. So obviously, there is a need. Secondly, the technical side of it, with smart meters, smart grid, all these states talking about these kind of things, you can have smart meter to actually monitor and control the water pumping schedules and align it with the grid. When the grid is having, say larger solar or wind, water can be pumped, stored during those periods. So obviously, the regulators will have to be informed because the wisdom will not fall on them like manna from heaven. It has to come from the experts, the sectoral experts. So they have to be made aware that these are the things you can do. Otherwise, if the act mandates, they will come up with a regulation. And that regulation will remain a piece of regulation. Just to say that, okay, we have notified all the regulation mandated under section 181, but how are they implemented? That implementation part, the discoms will have to be made aware that, look here, there has to be a trade-off. Trade-off in the sense, what they lose. Maybe because of stranded PPA, they may end up paying 200, 300 crore. But what they save in terms of lower cost of power purchase, number one. Second, cost of transmission, cost of congestions would be enormous. Therefore, there is a need for them to understand these things so that they implement. And it will be a win-win situation for them and not a revenue-losing proposition if they go in for demand proposition. And for these things, pilot projects are, if you can demonstrate, as our friend from Mumbai said, that it can be a win-win situation for larger integration of renewals and cost savings from the consumers. As rightly said, that in almost all the states, there's a gap between ACS, that is average cost of supply, and average and the ARR, average revenue requirements. So that gap has to be narrowed with these kind of interventions. Yeah, that's all.
Thank you, sir, and that was very comprehensive. Without losing any a beat here, I'll ask Sujatha to come in and give us the discounts perspective to what Dr. Verma said, especially that Tata Power is a leading innovative discom, and you experiment with a lot of pilots and programs and opportunities. And also, on the other hand, you also have smart metering, smart meters rolled out, TOD tariff revised, latest regulations are in place, offering opportunities to wider customer categories. What's next? What is stopping? Or what is the vision here? Right.
Okay.
Even if you're not, if you're not looking behind and if you're looking ahead, what do you see? What is the ambition for Tata Power? Thank you.
Thank you, Rashmi. As correctly said by Mr. Sanjay, that it's really difficult for a DISCOM to bridge the gap between ACS and ARR. Because as you say, demand changing seasonally, like in winter we have low demand, in summer we have high demand. So during winter we have excess surplus which need to be disposed in market. Otherwise, I will be penalized by additional deviation charges, even for having the surplus. And in summer, definitely it's a for very short time period where I need to purchase power from a market at very high rate, which is again affecting my power purchase cost. And with the long-term PPA, whatever I'm having, again the surplus where I'm not having is a problem. So now we have many solutions on supply side. If you go as a DISCOM, we have a SCADA system, we have a power portfolio management system, we have energy management system, and whatever balancing we can do from supply side is already done with a lot of technology intervention. Now it's a time we should go for a demand side where we can develop such portfolio from demand side that uses that which we can use to bridge the gap between demand supply. The BMC project, which water pumping, what we have done, it's one of that. And other than that, even Tata Power has taken many innovative initiatives. Like for the this is what I'm talking about is all demand side. That we have done a behavior demand response, automatic demand response. Even we have tie-up with a consumer where we have asked them to increase their demand, increase their load when I'm having surplus. So only such type of interventions are going to help us as a DISCOM in a long run. Now the supply side, there is a very few, you can say, scope available. That's it from my side, Rashmi.
Got it. Thank you very much. But I suppose the issues of standard PPAs will still come up there, is what I can sense. But I'm sure we'll discuss this another time. I will ask Giorgia to step in here and sort of share some of the international experiences in demand flexibility or demand response that you see either in peer countries that can be compared with India are useful for the conversation here from SEforALL's engagements.
Thank you, Rashmi. I have to say that the work sort of that has been going on in India is quite advanced, right, in terms of peer countries. I think one key opportunity that we are looking into as part of the SEforALL work, right, we're working with many countries in the Global South. So yeah, many peer countries to sort of model the long-term transformation of their energy system to achieve net zero goals, for example. And I think there is a key opportunity to integrate demand flexibility and sort of the modeling work on demand flexibility that we are doing in India into this type of transformations and this type of long-term plans. So, for example, SEforALL has developed this energy system model that it's a least cost optimization model to transform the energy system both on the demand and the supply side to achieve net zero by a certain year. And that the final result is sort of open source and sort of validated scenario that comes with an investment plan, an investment roadmap. So the key question there is how do we learn from how do we take these demand flexibility opportunities that are typically on short-term horizons and sort of integrate them into this long-term planning to help with basically plan for grid modernization and peak load management and load management in general, not only in the medium term, but also when we look at long-term transformations of energy systems, because there is a key opportunity to sort of reduce or sort of avoid and defer investments in additional renewable energy or additional supply capacity if sort of we prioritize the demand side management first. So I think this is one interesting sort of opportunity that we're looking at. And yeah, so going on both sides, right? How do we bring this long-term planning to the case of India, but also how do we we're looking to how to integrate the modeling capabilities into like other countries that can learn from the India experience.
Fantastic. And it's an evolving space, and more information to be added, contributed, and built as we go is what I see. Before we open the Q&A, I'd like to quickly come back to Sumedh and Mr. Charankar for quick last questions. Sumedh, can you share a few international examples that very quickly for our considering the power sector conditions in India and the limitations, what will be the next best opportunity for us going ahead? And if you can take public waterworks or even high-rise buildings, which I'd like to ask Mr. Charankar also, but high-rise buildings, pumping opportunities, all of these are opportunities. What comes to your mind, and a few thoughts would be very useful if there is something that we can take from other countries.
Oh, sure. Thanks, Rashmi. This is a good question. So there are two aspects which we should consider. One is large loads with small consumers and large number of consumers with small loads. So which is better? Because what happens when you go for large number of consumers with small loads, the execution of a program becomes a real challenge. And when we talk about like water pumping stations, I mean, these are small consumers with large loads. So they become a good target for us to start with, to begin with, to show some impact. And if they are contributing to peak, then why not? I mean, because one aspect which I always say in terms of the geographical context is that at times these kind of consumers are either subsidized and you are basically paying out of pocket and using some other mechanisms to provide or to meet that gap which Sanjay Verma ji was mentioning about. So naturally these kind of consumers become the right candidates for us to pursue with. We have certain examples outside. In fact, if I say, in fact, South Africa, their peak was getting into winters and they started using geysers as one of the mechanism. Water pumping, many examples, public water works, centralized centralized utility, water pumping and residential colonies. These examples are amply found in US, so that is absolutely there. In UK, we have seen examples where you have utilized public water works for load scheduling. So definitely these are proven. Although the context is different, the nature of utilities are different. But when I talk about India, because we have now some deep level of technology already there, communication, cheap communication, smart metering at many places. I think we should start focusing on large loads and small consumers, and public waterworks is a very good example to begin with. So yeah.
Thank you for that positive reaffirmation of all our efforts sort of converging in some sense. Mr. Charankar, the last question, and as you bring the largest experience in public waterworks, what are your concluding thoughts, especially if there are operational constraints that can affect the opportunity that we all are sort of thinking that could be one of the demand flexibility area that we could prioritize, but what could come in the way and how can that be addressed or what should we bear in mind while looking at public water works as an opportunity for demand flexibility?
According to me, there are about two areas where there are opportunities. One is bulk water supply systems. That is the part where the public water works play more important role. The quantities are huge. The only constraint I see is the construction of the reservoirs. At present, the water reservoirs have been almost used to their maximum capacity. See, somebody shifting the load from peak hours to non-peak hours needs to have a water storage of the huge quantity, which has limitations. See, for example, from the safety point of view, hydraulic safety point of view, the height of such reservoirs necessarily has to be in the range of 3 meters to 5 meters, because otherwise the forces on the walls increase considerably. Second thing, when the water is required to be stored during non-peak hours, huge quantities of water will have to be stored, and this will need construction of large capacity reservoirs at elevations, say like Bandufil, like Worli Hill, like Ghatkopar. See, practically all the hills in Mumbai are already occupied by BMC. Absolutely, there is no scope for construction of any more reservoir in the city. Leave apart for the increasing the height of the existing reservoirs. That is one thing. But the another opportunity that I see is pumping of the water in high-rise building. Of course, these consumers are in large numbers, and their energy requirements are to the extent are not to that extent. They may be in the order of about 30, 50 or maybe 50 kilowatt or 70 kilowatt. But such numbers are very huge. See, all cities in India are growing vertically. Everybody has seen that. And the responsibility of public water works, particularly drinking water works, ends when the water is supplied at the underground tank. Water is received at the underground tank. Then it is the responsibility of the society or the association of the members to pump the water from underground tank to overhead tank, and from overhead tank through the down tank, everybody receives water. That is the normal supply in all high-rise buildings. See, in Mumbai, I understand there must be at least 2,000 to 3,000 million liters of water being pumped at an average of height of about 50 to 60 meters. See, typically all buildings are going up to
Is this network frozen?
I think we lost Pramodji, but Pramodji was making an excellent point.
is going to be.
Pramodji, you are back.
So it's hello. So these consumers may be in a large number, but with a smaller electrical load, will gives a good opportunity to shift the load from peak hours to non-peak hours. This is the one of the great opportunity I have seen. Of course, there are some initiatives taken by some organizations, but real incentives, smart metering, whether such type of investment will help them, will have to be, the awareness will have to be created among those. This is a great opportunity according to me.
Thank you, sir. Did you want to, that was very informative and something for us to also look at in widening the opportunity that we are examining currently and built around it, but also understand what should be minimum in place to take, to aggregate this large opportunity that is in smaller numbers. So Sumedh, did you have a last one, like half a minute thought?
Yeah, I was just Pramodji was making a very valid point. So I always see that I live in a high vertical rise building and we have central power pumping station. And I always feel that this is a very good opportunity for demand response or demand flexibility. Only thing is the modeling for the incentive part, where I, as a consumer or as a residential colony, can receive certain incentives, it becomes more appealing. Number one. Number two is if we have a market for kind of aggregators who can aggregate and give it to utility, then things become less challenging. So I can fully echo with what Pramodji mentioned. And there is a huge opportunity here which can be tapped for flexibility. Yeah.
Well noted. I will now, I think we should open the questions. There are 3 questions at least, and I'll just start with one and direct it to one of y'all, or if anybody else is interested, you can always raise your hands. First question is from Desh Deepak Verma. I'm going to read it out, Desh, here, so that considering the time, we can just sort of keep going. What are the recent technological developments in pumped or storage technologies and simulation software is used? And I'm wondering who would be interested in answering this question. Recent technology development in pump storage technology and simulation software used. Both are slightly different, but is there, Mr. Charankar, would you like to answer that question?
Well, exactly that as such. So I'm working on a power plant on a smaller capacity for BMC. It's a combination of hydroelectricity and solar power plant. It's a floating solar plant on a water reservoir or on a dam site. Well, storage pumping working on a solar as well as on hydropower could be a good combination. That is, during daytime, the solar power can power the turbines in a pumping mode, and water will be pumped from a lower reservoir to a higher reservoir. And during night period, the same water which is pumped from on a reservoir will be discharged through turbines, generating hydropower, a sort of a combination. But I'm not much aware of the software, but such kind of combinations may be very useful, reducing the cost of pumping as well as reducing and generating the power. So that difference could be sizable.
Got it. And the follow-up question to that is like CTU or STU pump storage is more beneficial?
Sorry?
A follow-up question to the same question is if CTU or STU pump storage is more beneficial?
Oh, no, I don't have enough knowledge on that.
Okay. That's fine. We will then move on to the next question is, do we have the capacity to meet peak hour water demand using storage from non-peak periods? If so, what barriers and challenges prevent utilities from shifting the pumping load accordingly? I think we did, most of the conversation today was around the same question. So we can, if there is anything about the same discussion, there's any other thought, any other panelists want to pitch in, please pitch in. But otherwise, this was the, the central theme of today's discussion. I'll be more than glad to have any of the panelists to open up, unmute and sort of add a line or two here. But otherwise, we can move towards the next question, British. We also have Dr. Patankar here. Mahesh, would you like to come in and share any of your thoughts here, if you're not moving?
Yeah, sure. So I think I didn't want to break the party. This is an excellent discussion. So firstly, I must thank the panelists and the participants as well for very interactive session here. I just want to add a couple of things here. One is some kind of a rule-based heuristics that would get developed, and based on the known knowledge about the peak demand and the convergence thereof, and availability of low-cost renewable energy, one can sort of make those permanent load shifts, as we call. We use the jargon as PLS, which is the permanent load shift. But demand flexibility is also, in a way, insurance to the grid, wherein you have sudden peaks emerging and you have sudden high cost energy which is being procured by the system operators and the distribution licensees. And that's where some kind of a network operating center based structure, wherein you have multiple water pumping assets linked to that particular network operating center, and selectively we can ramp up or ramp down the demand side of the pumping load itself for shorter period of time, 15 minutes, 30 minutes, 45 minutes, 1 hour is it's a great opportunity. So just wanted to drive home the point here that while we would have reservoirs as a constraint, what we are also discussing here is how the system and the pumping operations can respond to the system integrity and the grid requirements itself in terms of frequency, voltage, and the cost of power procurement at that particular instance as well. So just wanted to add that point to the already enriched discussion here. Back to you, Reshmi. Thank you.
Thank you, Mahesh. Thank you for your concluding remark and sort of converging, sort of tying all the loose ends that we sort of had the conversations held now. A quick summary of our thoughts.
If I may also sort of
Yes,
talk
yes.
about some other sector that sort of is possible in the water pumping systems itself. We have seen a lot of drinking water schemes coming from Jal Jeevan Mission in India and several parts of India, where you have typically underground water pumping and you have some kind of a centralized elevated service reservoir, storage reservoir. And this happens in states like Himachal, Uttarakhand, Punjab, Haryana, Madhya Pradesh, where you have drinking water schemes being promoted by the governments. And that's where you are actually looking at a constant head and constant volume of water that gets pumped. And you are typically ensuring that you have a 1 to 2 days of reservoir capacity already created in the form of elevated service reservoirs. So you have public water works in the urban centers, and you also have public water requirements and the drinking water requirements in the peri-urban and the rural centers. So I think we have that also as a cohort, which again, as Mr. Charankar mentioned, and Sumedh alluded on that as well, and so did Dr. Verma. You have multiple users with smaller number of capacity. But I think if you add that up and you have only one client from the discounts perspective, and I'm sure Sujatha from Tata would agree to that. You have one customer to deal with instead of having to deal with multiple customers. So I think that's another opportunity which we can't sort of ignore when you look at water pumping as a demand flexibility asset that's now getting created through some of these discussions as well. Yeah, back to you, Reshmi. I promise I won't jump in again. Thanks.
I think that's a problem. We have a question from Kanta Mystery, which I think will be the last question, but it's a two-part question, basically two questions, but both useful. He's asking how to design incentives for volunteers who participate in DR programs, upfront or afterwards, so that to actually achieve peak shaving to the utility. Sujatha, would you like to take that? Yeah, thank you.
Yes, sure. Regarding the incentive, like Tata Power, we have done a many behavior demand response as well as automatic. So we have designed the incentive depending on the consumer category. That if it's a higher like a CNI consumer, which is commercial and industrial, we have given a financial incentive as well. And there is a lucky draw for the residential, and we have given a point system as well. So there are different combination of incentive which we are like designed to make the program successful. And definitely there is a mechanism to check whether there is an actual peak shaving to utility through their, like for behavior, through their activity, And in automatic, definitely we have control of their appliances where it's clearly visible to us whether actual demand is reduced or not. And the third one was how to convince utility regulator that the DR is not load shedding program and even through the advantages to meet. Okay. This is really a very important question because it took us around, you can say, a 4 month. And when we are approaching a consumer to convince them that this is not a load curtailment or load shedding, this is your contribution towards sustainability. And believe me, even we have received a very positive response from many industry where the financial incentives are not given, but we have given them a certificate to saying that this is your contribution towards sustainability. This is how you save a fossil fuel generation and shift it to a renewable generation. We have done a lot of outreach programs. We have done a lot of PR to our social media as well as email everywhere. It is extensive, like say, work to convince that how the demand response is important and how the demand side flexibility is needed now for India.
Can I just
Yes,
add
Sunil.
something?
Yes, please.
Very nice, Sujatha ji have explained it so nicely. Just few points maybe for Kandar also to understand that when we talk about load shedding, then load shedding basically de-energizes the community. So that is where your essential services like hospitals, transportation, everything gets impacted, number one. Number two, whenever there is a load shedding, there is a significant wear and tear of the infrastructure, like circuit breakers and all, they get really impacted bad. And third point is the comeback load after load shedding. It is very difficult for any discom to manage. So if we are able to communicate these three aspects to any discom, telling them that the targeted demand response or surgical demand response through these kind of incentives like pumping, they will be able to understand the value of it. That is something which I just wanted to add.
Thank you, Sumedh. Actually, those were three good points for reference and also for clearly positioning the communication of why load shedding, demand response, or demand flexibility is not load shedding. With that, that final note, I'd like to quickly thank everyone for the contributions. But I'd like to ask Yashraj to just quickly summarize in a few sentences the highlights of our meeting today. Yashraj is a project manager with us at MP Ensystems, leading power sector activities.
Yeah, thank you. So I would like to take a moment to summarize some key takeaways from this today's session. So we have explored the critical role of demand flexibility in optimizing energy use, reducing peak loads, and ultimately enhancing grid stability. Our esteemed panelists have shared valuable insight on how technologies and regulatory framework can facilitate better load shifting strategies in public utility. So, real-world example case studies have highlighted both the successes and challenges faced in implementing these measures, emphasizing the need for the holistic approach. I think that combines policy support, financial incentives, and technological advancement. So I think, and one of the most important message from today's discussion is that peak shaving is not just about reducing cost. It's about also building a more resilient and efficient and sustainable energy future. So as we move forward, integrating renewable energies, storage solutions, and also demand response program it will be very crucial, making the strategies more effective. So yeah, I'd like to extend my sincere gratitude to our panelists for sharing their expertise and to attendees for their active participation and asking questions, and to everyone who contributed to making this webinar a success. So we hope today's session has sparkled new ideas and collaborations that will help drive impactful changes in the sector. So yeah, so if you have any like if participants have any further question, they can reach out to peak@MP Ensystems. You can send your questions if you have any. And thank you once again, and we look forward to seeing you for further discussion. Thanks.
Thank you, Ishraj, and thank you, everyone, panelists, and all the participants.
Thank you. Thanks a lot.
We are we are continuing this webinar series every fortnightly. So 2 weeks from now, I think the next one is on 26th March. 14 days from now, we will have the next webinar, which will be on the energy storage, thermal energy, heating and cooling demands, demand flexibility opportunity for heating and cooling, meeting heating and cooling demands in buildings. We look forward to your participation and contribution in some way or the other. Thank you very much. Have a nice evening. Bye-bye.